Dilate point M, -6, -12, about -1, -1, with a scale factor of 1/2. So first, we have a scale, so C is equal to 1/2. Our preimage is located at -6, -12, and our point of dilation is at -1, -1. So first we need to find the difference between these 2 points. We need to find the difference because this allows us to find the location of the preimage in relation to the point of dilation. So the point of dilation, when we find the difference, becomes like a kind of like becomes like the origin. So I'm going to use M to represent the first variable of the point. It would be -6 minus -1. M would be at -6 plus 1 would be -5. N would be at -12 minus -1. N is at -12 plus 1 would be -11. So the point would be at -5, -11. So if the preimage was at, if the preimage was being dilated from the origin, it would be at -5, -11. All right, and so from here, typical rule would be x comma y, cx, cy. So instead of using x comma y, the preimage, we're going to be using -5 for that x and -11 for the y. And lastly, we do have to add the point of dilation to offset its distance from the center. And lastly, we do need to include the value of C. Alright, let's just plug this on in to get where the location M would be when it's being shrinked. So we have -6, -12 is where we start, and then we start plugging everything in. We have 1/2 of -5 plus -1, and then we have 1/2 times -11 plus -1. So if we were to highlight everything, what's important here, our C value is the 1/2, so it is getting shrinked. Then we have our M value, X. Then we have our Y value, or N value. And the point of dilation, -1. -1. Okay. So what we could have here, we can do a decimal even, it doesn't matter. -2.5 plus -1, and we have -5.5 plus -1. So we get -3.5, -6.5. And that would be the location of M prime.